roots. So when you have addition and subtraction, right, those things undo each other. If I have, if I have 3 plus 4 equals 7, then I can undo this addition, right, by subtracting 4 from both sides, and I get 3 equals 3, which is true. So subtraction and addition cancel each other out. Multiplication and division cancel each other out. So one question you might wonder is, if I have something like, x squared equals 16, something this small, like a power of 2, we can kind of just think about it, right? We can say, okay, well, what number can I square and get 16? And 4 works, as does negative 4. But there should be a way for us to do this in case we had something that was a little bit more complex. And the way that we undo exponents is with roots. Okay, so roots undo exponents. The most common kind of root that you'll see the most often is the square root, where if you have a square power, right, I can take the square root of both sides, so that the symbol, it looks a little bit like the old division symbol. It's kind of like this. It's got this little thing here, and then like a check mark that comes over. And what this means is get rid of the square, right? Undo the exponent. So when I do the square root of 16, I'm asking, what number can I multiply by itself to get 16? And that would give me 4, right? So there is one subtle difference, which is that if I just ask you, if I just say, like, what is the square root of 16? The answer is 4, okay? This is called the principal square root, or the principal root, okay? But sometimes you'll be working up here, right, where you have an equation, which is x squared equals 16. And when you're solving an equation, you take the square root of both sides, and there's actually 2 answers, right? And what we have to do when we do that is we kind of denote that's the case by saying that x is equal to either positive or negative square root of 16. Because if we only have the root there, we're only talking about the principal square root, which is the positive answer. We need to intentionally add a plus or minus sign up front to indicate that the negative answer would also work, right? The reason for that being that if I took negative 4 times negative 4, right, if I multiply these things together, 4 times 4 is 16, I have a negative times a negative is a positive, so I just get positive 16. Positive 4 times positive 4, also 16, right? So we'll look at a couple more here, like if I ask for what's the square root of 25? I'm thinking what number times itself is equal to 25? Well, that would be 5, right? Try these next two. Pause the video for a second. Square root of 100, square root of 9. So think about what number do I have to multiply by itself to get these two things. So for 100, it would be 10, and for 9, it would be 3, right? But again, if I were doing this in the context of an equation where I said, hey, I have x squared is equal to 36, what's x? Don't just write that x is equal to 6, right? Don't just write, well, I can take the square root of both sides and say x is equal to the square root of 36, because it's really equal to positive or negative square root of 36. So if you're doing this in the context of an equation, you need to have both, because both things I could plug into x and make it true. But if you're doing it in the context of just like someone asks you, what's the square root of a number? It's just going to be the positive one. That's what they're asking for, okay? Good. But we can undo, so yeah, positive or negative 6 to be our answer here. We can undo other roots as well, other exponents as well. I could say instead, what is, the 4th root of 16? And you'll note that when I write this, the 4th root of 16, I put a little 4 up in the corner here, okay? This tells me, like, what kind of exponent I'm undoing. This tells me how many times do I have to multiply the number I'm looking for before I get to the number in here, okay? In the square root, you could put a 2 if you want. Nobody really does, because it is so common that if you don't see one there, it's assumed to be a 2. If you want to take this like any other kind of root, you need to indicate specifically which root you're taking. So the 4th root of 16 is saying which number do I have to multiply by itself 4 times in order to get to 16. And for this, it's helpful to kind of consult as you're learning all your powers and exponents and roots and everything. Consult a table or a chart that just has all the different powers in it. But the more you do it, the more you'll be able to kind of pull these out quickly, just like when you were learning to, your times tables and things like that. So here I would say, okay, well, a number multiplying by itself 4 times to get me 16 is going to be 2, right? So I do 2 times 2 times 2 times 2. This gives me 4, and then 4 times 2 is 8, and then times 2 is 16. So the fourth root of 16 would be 2. Okay. Why don't you try one or two other kinds of roots? So we'll put up, let's say, the cubed root of 27. So here you're looking for a number you can multiply by itself 3 times to get 27. And yeah, let's just try that one. So pause the video, see if you can get it. So this one should end up being 3, right? If I do 3 times 3, I get 9, and then times 3 gives me 27. So the cubed root of 27 is 3. And again, feel free to consult a table or a chart as you're starting these. If you get something that you're looking at and you're like, wow, I really don't think there's a nice number that I can get from this, right? Like if I asked you instead for the cubed root of 16, right? Is what number multiplied by itself 3 times to get 16? There is no number. There is no integer that has that property perfectly. But there is a number that will do it, right? But you're gonna have to use your calculator to get it. Just like if I asked you what's 2.468 squared, I mean, you can do this on paper, but you're not gonna be able to do it in your head very quickly, nor are you gonna be able to look at a chart very quickly, right? To figure it out, this is where you would turn to your calculator. Same idea here. If you have the cube root of 16, you would turn to your calculator. You're gonna find there's a square root button on there, little check mark, and there's one that has a little X next to it. So you'll just type in like the button 3, and then the button that looks like this, and then you'll type in 16. And if you hit enter after that, then it should give you a funky decimal, something like 2.519842, so on. So you won't always have nice things, but if you're not using a calculator, you can only really do roots of nice numbers unless you learn some tricks. There are some really cool tricks that let you estimate non-integer roots, but we're not really going to worry about those for now. So that is it for roots. In our next video, we're going to talk about kind of extending the idea of roots and corresponding them more tightly to exponents. We're going to talk about what's called rational exponents or fractional exponents.